Okay, so in the last lesson we drew some pictures. Our first example, we had a camera pointed up at a shuttle, and we drew this triangle. Anyway, let's get to what we're really shooting for, which is the next couple steps. So we have the triangle drawn, so what do we do now? Well, in this particular example, we're trying to solve for the angle, which is theta. Notice we're given the opposite side 300, because it's directly opposite from the angle, the adjacent side 750. So our next step is going to determine which trig function involves opposite and adjacent. If you said tangent, you are correct. So step 2, go ahead and write that out, determine the trig function. Like we said, that's going to be tangent because it involves opposite and adjacent. Remember, it's either sine, which is opposite over hypotenuse, cosine, adjacent over hypotenuse, or tangent, opposite over adjacent. The way to remember that is SOHCAHTOA. Of course, you can also use the other 3 trig functions, which are just flipped versions of the first 3, secant, cosecant, and cotangent. So that's step 2. You just write out the trig definition of the trig function you're using. So in this case, it's tangent of theta equals opposite over adjacent. Then step 3 is very simple. You're just going to plug in known values. This is why we draw a picture, because now we can easily see that the opposite side is 300, adjacent is 750. So we're plugging those in for O and A, just like so. And that's all we're going to be doing today, is just setting up the equation. So for the first example, we've set it up. We have tangent of theta equals 300 over 750. In the next video, we will actually solve for theta, and we'll figure out what that actually is. But for today, we're just setting up the equation. So that's example 1. Let's set up the equation for example 2. Example 2, here's our triangle. We have the plane flying 7.5 miles away, and it's 6 miles high. So again, we have these 3 things. We have theta, we have 6, and we have 7.5. How does 6 relate to theta? If you said opposite again, you're correct. It's directly opposite from theta. How about 7.5? Well, since it's opposite the right angle, then we would say that it's hypotenuse, right? So we have opposite and hypotenuse. Which trig function involves opposite hypotenuse? If you said sine, you are correct. So the way to set this one up is sine of theta equals opposite over hypotenuse. Okay, so we have sine of theta equals opposite over hypotenuse. That's our trig function. Same step 3 as before. We're going to plug in known values. And again, since the opposite is 6 and hypotenuse is 7.5, we're going to plug in 6 for opposite and 7.5 for hypotenuse. And that's it. Again, all we're doing today is just set up the equation. So it's actually quite simple. Again, in the next video, we will actually solve for theta, which is what the question was asking. All right, example 3, we have this picture drawn. We have 30 degrees for our angle. We have our opposite side x, and we have, this would be the adjacent side, right? Adjacent of 30 next to, but not the hypotenuse, is 500. So let me ask you this. Since this is opposite and this is adjacent, which trig function involves opposite and adjacent? Well, again, that goes back to example 1, which is tangent. However, in this case, we're solving for an unknown side. We're given the angle. So we still write the trig function we know we're going to use since it involves opposite over adjacent, namely tangent of theta. But when we plug our known values in, this time we're plugging in the angle theta 30, since we already know that the angle is 30. For the opposite side, we are going to be plugging in x, because that's what we're trying to solve for, this height, which you could also call h. And for the adjacent side, we're going to be plugging in 500. So again, that's it as far as setting the equation up. In the next lesson, we will figure out how to solve for x. That'll be our last video series. Now, our last example involved an airplane flying at a certain altitude, and it's kind of like example 2, only in this particular example, we know the angle that we're looking at the plane is 33 degrees. We know the opposite side is 6, meaning how high the plane is. The real question we want to ask ourselves is how far away are our eyeballs from the plane, right? So we're solving for what? We're solving for the hypotenuse. So in this example, we have the opposite side from 33, and we have the hypotenuse, and this goes back to what? It goes back to sine, right? So we're going to be using sine in this one. Unfortunately for these examples, I didn't get to use a cosine example, but you would use cosine if you were given the adjacent side and you were solving for a hypotenuse or something like that. So it's sine of theta equals O over h. Since theta equals 33, we're going to replace theta with 33. And since the opposite side is 6, O is going to be replaced with 6. Since the hypotenuse is x, h is going to be replaced with x. And again, that's actually going to be it for now. We just set the equation up. In the next lesson, we will solve for x. Now, we'll say you could have used cosecant for this, and it might have made it a little bit easier. You would have gotten cosecant of 33 equals x over 6. At any rate, we can solve it with either trig function. That's it for this particular video. Like I said, in the next, we will end up solving for these values. If you have any other questions about setting up equations for solving practical trig problems, let me know.